Alright, this video is going to be an introduction to charge. Some of the stuff you'll already know and some of the stuff will be new to you. Okay, so there's two kinds of charge. There's positive charge and there's negative charge. And when you bring charge that is opposite to each other, it attracts. It'll feel an attractive force. So if I bring a positive charge near a negative charge, what I get is I get attraction in the direction of each other. They attract. So the plus charge will feel a pull toward the negative charge will feel a pull towards the positive charge. However, if I bring two like charges, two positive charges, or two negative charges together, I see that the positive charges will feel a repulsive force toward each other. So they'll feel a force away from each other, and the negative charges will feel the same repulsive force. So opposite charges attract, negative charges repel. You probably already knew that. Okay, so how does an object become positively charged or negatively charged? Well, inside an atom, there's two kinds of charged particles. There's protons and there's electrons. When you have an equal number of electrons, which are negative, and protons, which are positive, when these two particles or subatomic particles are equal, they will be neutral because you have a balance of both types of charge, both positive and negative. However, if you have an unbalanced amount of charge, you have what we call an ion, and you can have a positive ion or a negative ion. A positive ion is an atom where you have more protons than you have electrons. Remember that protons are positive, so if you have more of them, you'll have a more positive atom. If you have more electrons than you have protons, you will have a negative ion because electrons are negative and protons are positive. So therefore, if you have more of them, you'll be negatively charged. And so the negative ion is negatively charged, the positive ion is positively charged, the neutral atom has no charge. Charge is conserved. Charge cannot be created nor destroyed, but it can move from one place to another or from one object to another. For example, if I were to have something like a plastic rod, like you might have a plastic baseball bat in your toy chest at home from when you were a kid, and I would rub that neutrally charged plastic baseball bat or plastic rod of some kind with a cloth that it was also neutrally charged, what happens is I can actually rub some electrons off of this rod onto, these are my electrons going to my soft cloth, onto my cloth, thus making the cloth negatively charged and the plastic rod positively charged. And the amount that this cloth becomes negatively charged will be the same amount as the baseball bat or other plastic rod becomes more positively charged. So it can't be different. It has to be equal and opposite amount of charge difference. Another way, other than rubbing something and moving electrons physically off it, is called charging by induction. And charging by induction sounds kind of complicated, but it's actually quite simple. So if I have, for example, a sphere here, and on top of my sphere, which is sitting on the ground, I have an insulating stand. Insulating stand. Meaning that electrons can't pass from this sphere into the ground directly through this stand. It blocks the flow of electrons that way. And the sphere on top of this starts off with a neutral charge, meaning it's got an equal number of positive and negative charges all around it. Okay? So, if I were to bring in a charged object toward this stand, like a rod, let's say this rod is very negatively charged, so I'll draw negative signs all around it. What happens is the negatively charged electrons here make the negatively charged electrons in the sphere want to run to the other side because they're feeling a repulsive force. And if I were to take a wire and attach this wire to the ground, which is called grounding or earthing, which is something to remember. This is grounded, or it could be called earthed, meaning we're giving the electrons away where they can flow from the sphere into the ground. Then these electrons that are feeling a repulsive force from this rod can then escape. So let's say maybe all of these electrons escape down into the ground to run away from this negatively charged rod that's coming at it. And then if I were to remove the ground, so I sever this wire, I return the sphere back to its state, I remove this rod, what I would have was a positively charged sphere, but this negatively charged rod would maintain its original charge. However, the Earth would have gained the charge from the electrons that escaped. So now the sphere is positive, the Earth is more negative, and because this is an insulating stand, electrons can't flow back into the sphere to return it to its normal charge. And that's charging by induction. We measure charge in coulombs. Coulombs is the unit of charge. A coulomb is defined as the charge transported by a current of 1 ampere in 1 second. So we're going to get into this a lot more in the future, but basically that's saying if I have a wire, I'll draw it really zoomed in, like a tube. So if I have a wire, and I have a bunch of electrons in the wire, and these electrons equal 1 coulomb of charge. Sorry about that. These electrons equal 1 coulomb of charge. That means that if this 1 coulomb of charge flows through this point right here, I'll call it point P on the wire, in 1 second, I would have 1 ampere of charge flowing through there, and so I would say that would be 1 coulomb. So coulomb is a derived unit because it's derived from the amount of charge that can flow through a 1 ampere wire. Another thing to remember about charge is called the elementary charge. So all electrons and protons are the same. All electrons have a charge of negative 1.6 times 10 to the minus 19 coulombs, and all protons have a charge of 1.6 times 10 to the minus 19 coulombs. Electrons and protons have an equal yet opposite charge, equal in magnitude, opposite in charge, and we call this the elementary charge because they're both the same number, so we call this number 1.6 times 10 to the minus 19 coulombs the elementary charge.